So hi everyone, I'm going to be talking about some of my master's research which looked at niche partitioning in early Jurassic ichthyosaurs. This picture on the screen is called Juria antiquia. It's one of the earliest pieces of paleo art and it depicts the paleo environment of the early Jurassic of Lyme Regis. Obviously some of the reconstructions are a little bit outdated now, but it shows quite nicely the marine reptile diversity in this area. In order for so many to coexist, they need to occupy a different role in the ecosystem, and this is known as a niche. And niche partitioning can occur on various scales, for example, diet and tooth morphology, spatial separation, so maybe different areas of the water column, or some scales like temporal variation that we can't see in the fossil record. So my research was aimed at looking whether or not these niches were partitioned according to tooth morphology. There are two schemes which have been used in the past to classify the tooth morphology of these ichthyosaurs. The main one is by Massare. It's used across marine reptiles. She compared the teeth of marine reptiles with the teeth of modern fauna and drew conclusions about their diet. The other one is by Bucchi, and she criticised the Massare system and created her own one. So what I did was I combined the best bits of both as it applied to my ichthyosaurs and measured various tooth and jaw characters and subjected them to analyses in past. What I should say is that since I finished my master's, the species identification, particularly of Ichthyosaurus, has changed considerably. So I'm currently in the process of updating my graphs and my results to reflect this. So what I'm presenting to you now are some of the main results, but there are other things which are currently in the works. So the main result that I got is about ontogenetic niche shifts, and this is where the juveniles of one species occupy a different niche to the adults, to prevent them from coming into competition with one another. And this was found in two different taxa. First is Ichthyosaurus. Now, unfortunately, the taxonomy isn't great, so a lot of the specimens couldn't be identified down to species level. But what you can see is a shift from relatively large, quite slender teeth with fine striations towards more robust, strongly striated teeth in the larger specimens. And I'm working on narrowing that down to determine how the juveniles of one species might have coexisted with the adults of a smaller species, for example. The other shift was in Temnodontosaurus plateodon, where specimens which are thought to be juveniles, so that's at the top, have very robust teeth, very strong striations, and a completely circular cross-section morphology. Whereas in the adults, it's completely different. They have a laterally compressed cross-section with at least one, possibly two, very well-marked carinae, and a completely smooth external surface with no striations or ridges. So it's very different. Unfortunately, the species is not well known, so the ecological implications of this can't comment on at this time. One of the most unusual ichthyosaurs that I looked at was Excalibursaurus. This is from Somerset, and it has an extended overbite of the upper jaw over the lower jaw, and this overbite has ventrally directed teeth all the way to the tip. Now, in past literature, it's usually referred to have a similar sort of ecological niche as a swordfish. So the swordfish Xiphias uses its extended rostrum to slash at schools of fish and then decapitate or destabilize the prey. However, the swordfish has a very dorso-ventrally compressed snout, so it's quite flat with no teeth to the tip. Whereas in Excalibursaurus and its relative Urinosaurus, the snout is circular to the tip. And this is unique in all organisms which have developed an extended overbite. No others have teeth all the way to the tip and this sort of cross-section morphology. So it's likely it was probably doing something completely different. And finally, despite the poor taxonomic resolution of particularly Ichthyosaurus, there is a lot of overlap in the gills represented between different species, which suggests that they might have been partitioning niches in different ways. And overall, it was concluded that a tooth guild is not the same thing as a niche. A tooth guild is just one way of perhaps seeing how niches could have been partitioned, and that when assigning tooth guilds, that should be given to the teeth and not necessarily to the whole animal. So thank you very much for listening. I'd like to thank all these fantastic people, and I'd particularly like to thank Mayfield School, who I currently work for, who have very kindly funded my attendance at Volpar. So thank you.